Hello, everyone. Welcome to a new episode of our Lunch and Learn series, where we bring interesting topics from the world of tech and web development right to you. Remember that if you're watching us live, you can ask your questions in the chat, and we will answer all of them at the end of stream. If you happen to catch us later on, feel free to leave a comment. We will surely get back to you. Today, we have Edgar Ranchi with us. He works with our client, Lowest Risk. He is a full stack developer there, and he will tell us all about AWS Lambda. He will show us some use cases for it. Welcome, Edgar.
Okay. Thank you, Sebastian. Okay, let's start. Today, I will show you guys a little bit about AWS Lambda. First of all, we need to think how the AWS Lambda works. So, for example, and some advantages on how it works. AWS Lambda is serverless, so you can execute code without worrying about server. So this helps you to saving costs because you only pay for the time that the Lambda will run and not will pay like you have a 24-hour servers. So this is one of the advantages of Lambda, to be serverless. It's scalable, so you can adjust your code executions according to your resources, and AWS has the ability to handle with large amounts of requests. The other important thing is the approach you generally will use to implement AWS Lambda is we're using an event-driven approach. What this means is you can only trigger your Lambda when you need it, and we will see in the future slides how we can do that. So you can trigger your Lambda from any other services from AWS and from any of one of your SaaS applications. So let's start to understand better what AWS Lambda is capable of. Let's start with some general uses mentioned in the documentation of AWS Lambda. For example, file processing. Here we have a diagram about how the file process can be done. For example, a photograph is taken. You can implement the upload to a S3 bucket, the repositories of AWS, and you can set your Lambda to watch this Lambda, this S3 bucket. So the Lambda will only trigger, for example, when new files are added. Then your logic in AWS Lambda, generally it's used Python language to implement that. So you can do your logic here, for example, resizing the images, and then you can turn them available into your web mobile, tablets, and another size. Just as good to show you guys some types of Lambda triggers available are here. For example, here I'm on the AWS Lambda dashboard from AWS, and here we have a type of trigger, the events, but we can configure any type of trigger. For example, here we can use any services from AWS, and if you has something from your SaaS application or any other application, you can use an API gateway, which allows you to a lot of flexibility on how you can trigger that. So back into some other examples, after file processing, we have data stream processes. Just to mention, Amazon Kinesis is a service from AWS that it's used for when you receive lots of data in real time, like a waterfall of data from many places. You can connect this data to Amazon Kinesis, that has the ability and is able to manage this amount of data. For example, in social media, we have a lot of interactions. We can have likes, comments, comments with hashtags, and so on, views. So you can connect, you can grab this data from the social media. You can trigger your Lambda based on the activity from Amazon Kinesis, and then you can run your Lambda, for example, to analyze the comments and see what hashtags is inside there. Then from Lambda, you can save your data to Amazon DB or any other database as you like. And in the end, we can make this data of social media available for your dashboards, through analysis, to the business, take decisions, and stuff like that. Then after that, we have, for example, in considering the data stream, some examples of data stream process could be held data, stream data from applications. You can monitor, for example, the activity of a user on a website, for example, clicks, interactions, or anything you want. You can process orders in a asynchronous way. You can making data cleansing. It's very interesting to when you need to refine your data. Maybe analyzing logging, making indexes, social media, as I talked before. And this last one is one I want to call your attention, is about to IoT devices. So devices that work with the approach of Internet of Things, IoT, for example, Alexa, you can grab data from these devices and use this data to work with them in the AWS Lambda. We will show in the next slide some examples of it. For example, IoT backends. This is another interesting scenario. A tractor can have sensors. For example, let's consider it has a sensor to measure the temperature, and this could be sent to Amazon Kinesis through the internet. You can connect the Amazon Kinesis to these sensors to receive these data through an API or other triggers. Then when it's update Amazon Kinesis, you can trigger your Lambda, and here you can, for example, let's see this data on the temperature sensor is saying that some piece or part of the tractor is overheating. So it may, let's say that in your logic, you consider this an anomaly, and you want to, it's time to change that piece or that part of the tractor. And in the end, you can use this data to automatically doing an order for replacement parts, or we can add here a manual step that, it generates the order, but one person can review the order before to effectively do the order. So this IoT backend is very interesting to use with AWS Lambda. And here in my clients, Lower Risk, they has a system that uses something like that with the Lambdas. They have an application that reads data from trucks and drivers to compose a risk score for insurance companies. How does this work? For example, trucks and drivers can have data like how many accidents this truck or driver was involved, if it received some fine because of speed limit or things like that. So we can fetch this data from the systems that they have this, and through the Lambda analysis and other implementations, you can define a risk score for those trucks or drivers. So as less you have many less fines about speed limits or less involvement in accidents, you have a high score. So when the score is lower, probably your insurance will have a higher price. So it's an interesting use that they do using AWS Lambda and IoT backends. And we can remember that IoT, when you think about IoT backends, you can build several backends. So they can be web, mobile, or programming something properly in the device, IoT, or maybe any other third-party API request you want. So here an example of a mobile backend, similar to the others before. It's very common that, like it's happened in social media. For example, a user posts a status update. You can trigger, use it as your trigger of your Lambda, the Amazon API gateway that makes a request to API to see if there's a post or not. And Lambda can run the code to bring the friend list and initiate the update notification. So here we are using Lambda to send data to Amazon SNS. Generally, Amazon SNS is used with Amazon SQS. It's like both of them in using together. They act like a message system, like Kafka, RabbitMQ, or another system of messaging. So you can do, it's a common way to, when you need to trigger notifications or messages to a lot of clients. And in the end, the user can see on his front end the status update notification. So as you see, guys, Amazon AWS has endless uses in our day-to-day problems that we face. And right now, when we have every day, the amount of access to our systems gets higher and higher. So it's the time to always thinking how you can do that in a serverless way, or maybe in a events-driven way, or maybe in ways that you can render the data and using these resources to reduce the impact of just in using relational database. One of examples, when we think on AWS Lambda, that generally is implemented in Python, we can remember that machine learning implementations generally has something to do with Python and also with AWS Lambda to do this process. AWS Lambda, Amazon Kinesis, and another services that AWS has to work with big data. So big data is it's a thing that AWS can help us to manage that. And let's see a real case. I will show you guys in a few minutes the code as well, the implementation and how it works. But let's see a real case from the user where we use the AWS Lambda to solve it. So what's the requirement of the client? This is a real requirement. They need to integrate two systems, and the tech lead defined that we must use Lambda to export data from the system one to S3 bucket, so we can hit the API of the system one to bring the data and save this data to S3 buckets using a schedule event. In this case, the schedule event will be the event bridge from AWS. And I will show the details soon. So the system 2 can import and synchronize this data in the future. Basically, it's a simple problem, but we can see that depending on your amount of data, for example, for the system, the needs of you update the data is just one time per day. So you don't need to have a 24-hour server to manage that. You can only trigger your code, your implementation can run only one time a day. So it's a way to save costs of infrastructure. So, and the solution to do that is to using the Lambda programmed using Python to connect to the source API to the system one. We use it so the Sun templates, I will show you guys that you can write your Lambda and you can use the Sun templates to automate the process of create the entire stack on the AWS. So you can do the export the Lambda, the permissions, everything you want. You can automate the process of deploy your application on AWS. To understand better on this diagram of this solution, here we have the AWS event bridge that will trigger the process. The Lambda will connect to the source API, returning a JSON as usual. Amazon S3 will, this implementation will transform the JSON in CSV because the target system needed a CSV file to work. And then at the end, the target system can access this CSV file to an S3 bucket and do whatever it wants. Well, talk ship, so let me show the code of how this works. So here we have the code developed in Python. Basic, when you do a Lambda, you always have the function Lambda handler. It's one of the standards of AWS to work with Lambda. It will be your main function as well. So here you can have all your logic. For example, we start getting the token and the credentials to connect to the source API. So here we have the endpoints and all the stuff needed to access that API. Just to see more quickly, here I have the API, and the result will be something like a JSON file. So when I hit that endpoint, I had a list with JSON data, just that. And then here we can store these results here. For example, here we can have the bucket that we will save our return. And here we have the function that converts the JSON into a CSV file. So just think that inside your logic, you can do whatever you want to connect the API, convert it, fetch the results. In this case, you get in JSON and convert it into CSV, and then you can upload the file to the bucket. So with that in mind, let's show. This is the implementation as itself, so we can do whatever we want. And as I mentioned before, we can have the Sun template. It's one of the approach that AWS make available for us when you can automate the process of deploy. So here we can have the AWS serverless function, which is Lambda. You can point it to your folder of your code locally, and you can say, hey, this is under my Lambda function file, and the main thing that it can trigger is the Lambda handler, that main function that I mentioned before. So it will looking for the code inside this file, and we will looking for this function. Then we can set some things for some properties the Lambda. I will show in the future through the dashboard so it will be more clear. We can define which version of Python you use. You can define some things like, hey, I don't want my Lambda use just a limit of memory, a limit of timeout. Here, it's time in seconds. Here, we can do the events. As I mentioned, we are using CloudWatch events. So it's a schedule that we run every day at midnight to connect the API, fetch the JSON, transform it into a CSV. And we can automate the creation of the policies. So in this example, we need access to some SSM parameters. It's just a place for you to keep secrets, tokens, client ID, and things, general credentials to access an API or any other type of API. And so here I can configure that, hey, say that this Lambda needs access to the parameters, and this Lambda needs permission to put objects inside the S3 bucket. So here you can automate everything. And I now showing the AWS, what we will have. When we run that, we can run through local CLI commands that item, that template YAML file. And here, the cloud formation, we will see the entire stacks with all the resources. So it will create the Lambda, will create the trigger, the watch events, the CloudWatch events. It will create the permissions, and it will create the host to access everything. So for example, if you open the rows, we will see the same comments that I write here in the policies about SSM and S3 will be here. Probably here, we'll have the same instructions that I had there deployed automatically here. And the other cool stuff is the Lambda as itself. So automatically, let me back here. Here we have the diagram that AWS make for us available. Here we have the trigger events and the Lambda as itself. And here we can see the same code I have on my IDE. We can see the code here. So it can export your code, the same code, to the Lambda. We not need to wait until midnight to test it. We can, Amazon allow us to give you a test. So you can click it in the test, and it will execute the Lambda on demand. And here we have some of that information I talked in the start. So billed duration. So will be charged by Amazon by the time your Lambda takes to run. And here are some configurations, like the limit is 128 MB of memory. And here in the configuration, we can say that these parameters we define here, like memory size and timeout, will be appear here, like the timeouts and the memory and stuffs. So you can have everything in one place. And after we run it, let me see here, it's already running. Okay, it just get executed. So what we will do is do all that process of connect, fetch JSON, and convert to CSV and save on the S3 bucket. We can go to the S3 bucket. This is my target S3 bucket. I had some tests today, but probably we have a new file here. So it will convert the JSON into a CSV. And here I already download an example. So we can have a file with CSV containing all the data. So it's a simple solution, but we can think at this in very many ways to how to solve the problems. So I think, and now one of the future steps for this implementation is at these clients, when they get access to the third-party system, to the target system, we will start to do the another side of the implementation that will be using the CSV on the target device. They need to download the CSV and synchronize that data into that system. So this is one of approach of makes two systems synchronized with the data you want. So I think that's it. I think I cover everything about it. And now, if you guys have any questions, we are here for it.
Okay, thank you, Edgar. That was fantastic. Lots of things to show about Amazon Lambdas, and you showed a lot of interactions as well, which is the interesting part, right? It's not just the Lambdas themselves; they are not a new concept, but seeing how many things can actually trigger the Lambdas and that you can schedule them. That is where you can actually think of what use cases you have for it. Before we go to the questions that may appear on the YouTube chat, I have a couple of my own. If someone wanted to start with writing AWS Lambda functions, and using this as the new architecture for a minimal backend, would you suggest them to jump into the AWS console to write them, or should they use frameworks? We know that many frameworks exist for it. AWS has one. There's serverless framework as well. What would you suggest?
Sorry, can you repeat the question?
Sure. If someone new wanted to jump into AWS Lambdas, should they use the console to write it, or do you think that frameworks like serverless, for example, make the job easier?
Yeah, and as the approach we use it here, we chose to develop it not using directly. You can start directly to do some tests or writing code directly on the AWS dashboard. But my suggestion for better productive development is that you use an IDE of your preference. Here I'm using PyCharm, that's to work to Python. And let me show you here. So we can have this extension from the AWS Toolkit. It's a good extension that allows you to run your Lambda through your IDE and select your AWS credentials. So you can interact with the Lambda. You can run here like you are running it through the dashboard. So it's very interesting. And the other advantage is you can use the template approach to automate the process of deploying. So it's what I suggest in this case is to do an approach like that, but you always has the ability to create something from inside the dashboard just to do some tests. And about to use frameworks, I think it depends of the size of the project. So if you has like this, we are using pure Python, just Python, not anyone Python framework or anything else, because it's a small project. But when the project starts to grow, maybe it's interesting to think about on some frameworks to that.
Great. Additionally, what is the different use case of using this versus other architectures that just await for calls from the outside? Like, is there any other reason to use AWS Lambdas that does not involve IoT or receiving events from outside of a connected system?
Yeah, the main thing we can think when you use AWS Lambda is uh, to have a mindset of microservices approach, and to think and how you can save infrastructure costs just triggering your Lambda in an event-driven way. So this is the mindset that you can have in your mind when you see some type of problems, like the many of the problems we mentioned, like integration systems or the IoT backends, or maybe file processing. So we have many approaches that we can use. What you need to think is this data, we will need this data on real time or not, or because when you can work event driven, it's like you just trigger your entire system just when we want and then when you need. So you don't need to keep your server 24 hours a day turning on, consuming resources without needed. So I think the main thing is to have in this mind this type of approach: microservices, asynchronous, and event driven to save costs.
Okay. Thank you very much, Edgar. I think that's all that we have for you today. I hope you liked the topic. If you did, like the video. And if you want to stay up to date with everything web and tech related, feel free to subscribe to the Job City channel. Until next one, thank you, Edgar, very much for being here with us. See you in the next one.
Okay, thank you.